Oh ini. Iya. Ya. Bela ban makan. It's on. Be ya workshop ne ita hoto proativo. Kari hasa buat balung ne bela comprende tenke husu ita hoto hasa aprende. Sama-sama kita TLnog ne tenke existi tama hoto ne energy ne ya network operators group ne ya network operators group clear tuan liu American operators group ne tu irmai makan so ini explicane janok IDnog Indonesia network operator groups ne ni hamrik tinan sanuluana Eventu dalaciona tidak ne composto su engenheiros hoto engenheiros ba redeniang husi agência estado husi ONG husi órgão regulador sira hoto hamutu mak foi mele ita bele hamutu kore bele partilha conhecimento e halarang idane ita hana kata kapasitasaun baloron tolune ne ita hahu nia fundamento nia dasar ita hana para tenke proativo kare kia buat balon bela comprende bele husu ohin ita hahu mas para ese evento turma ita bele saya avançado ituang tamane mak loron tolune tenke fokus loron tolune ita aprende conceito nia basic ne depois ita se tamaya para nebe hotu tenke hahusu para hotu fokus hotu karikla comprende bele husu ita tenke hanoi para haru desenvolvimento bat capacitação timoroan tamasera ohin loron quando ita hotu assiste ia quase em sução governo hotu usa recursos externos usi liur mamai configura switch oane router oane tem que usar estrangeiro mak mai hane selu ho belasan ribu $10 por mês até 15 anos 10 anos baida ne hansa ita timoron profesional ne hane san traída maita penghiana tamboti da maita se how precisa configura switch oane router oane mak how tem que selu belasan ribu emarai lur mak mai halo idane makane ita ne lausukunan ita nia dependência ba economia botliu agora ba recursos humanos ita depende ba ema 20 tal anos ne labele hanesane amane ita hanoi ba ita prepara timoron so timoron mak tem que tama marketplace hodi halo buat sirane tombak
Okay, sorry about the delay. We'll have some technical configs done, then you will get the internet. I think without the internet, we'll not be able to practice the lab. So let's wait for that. but I'll continue with the presentation. But before that, there are some questions. So there are some questions. It's my first time to Timor-Leste, whoever asked this. But I really love this. That when I the airport, all the people are very friendly. And yesterday I was walking. Yesterday I walked 10 kilometers. Yeah, from my hotel all to. There is a mosque. It's called Al Nur Mosque. So it's about 5 kilometers, 4.5 kilometers from my hotel. I took the road, not the road, the garden and then playground and all the seaside area. I went to the lighthouse. Again started working, and I think it's similar to Bangladesh, my home country. Very friendly. I will ask my manager to send me again to Timor-Leste, inshallah. BPG. BGP will talk tomorrow and then day after tomorrow. Config will configure some IP addresses. This is basically a command in Windows machine. You can check your addresses, gateway, and more information. Similar to if config for Linux and Mac users. Protocol, routing protocol, we just covered a theory, but more is just the basic one. This is starting. So tomorrow, after tomorrow, both days we have like very extensive routing, theory and lab. BGP again tomorrow and day after tomorrow. Tomorrow we have OSPF, BGP, and day after BGP. Final question. So you promise that you are not going to ask that question, whoever write this. You promise, no question, okay? If I hosting to one network, but I want to another network, how to routing this? You probably mean the VPN. You are connected to here, but you local connection to your office center. That's a VPN. And any VPN itself is a there are several different UDP and TCP based, and you can do remote access VPN, you can do site to site VPN, you can do an IPsec. Nowadays you have WireGuard, PPTP, L2TP, different types of VPN. Side to side, you probably also have the MPLS VPN. Basically need VPN, and if you do it on your laptop, then you have like it's called remote access VPN. So you can do WireGuard, you can do Cisco, AnyConnect, you can do PPTP or L2TP, whatever works for you. I mean, different options. My laptop cannot get TL. It's a good question. Actually, we had some interruption here, and I think the team is still working. So the venue has the internet. So don't worry. Probably it will come back. Thank you. Okay, these are all like testing. So all good. Okay, I will start with the, I wanted to start the lab, but to start the lab, I need internet. If you want to access your router, you need internet. So for that, let's wait. Once it is done, we all get internet, then we'll start the lab, okay? But I'll start next presentation, and let's continue with, because otherwise tomorrow is going to be very hectic tomorrow, and maybe you will not be able to go from here till 8 p.m. You okay with that? We probably don't want time delay. Whenever there is a processing delay, because of NAT, this processing delay gets introduced. Now, if at some point, so let's say I'm using a big highway, but at some point the lane number is smaller. So let's say it was a 4-lane road. At some point in a bridge, it's like 2 lanes. Okay, that means you cannot now send 4 at a time. At some point there will be 2 only. So this is something happens in Ethernet as well. We know that my laptop has a 1500 bytes connectivity. Then at some point somebody manually changed it and make it, let's say 1300. So my 1500 will get, the last device will fragment it again, send it to the other side by 2 times. Like one is 1300 and second one is going to be, right? Something like, because it's limited there. In IPv4, this is how it works. Somewhere in the middle, if there is a limitation, they will do fragmentation by themselves. But in IPv6, the total path MTU is discovered by the source. So the scan and find out maximum in the whole path, not just in IPv4. I'm just thinking about myself and my next neighbor. I don't know about the whole path. But in IPv6, it's going to be discovered. And that's why it's called path MTU discovery. It's done, and then there will be an optimum MTU set by the source. So nobody in the middle needs to do any fragmentation, just to make it a little bit optimized. Okay? We'll see some slides. It has some slides. So no, yeah. Oh, it's connected. Okay, yeah. We'll do the lab after I go and find a good place to. So this is the IPv4, this is the IPv6 header. This is the header. Remember I told you that in layer 3 you will have some header. IP address will be mentioned. And I'm pretty sure you have seen this before. But which one is complicated? Which one seems complicated? Which one is complicated? Left side or the right side? Left side. Anybody here who thinks it is complicated? No. Okay. Yeah, you are right. Actually, this one is a little bit complicated. The right side, even though it's bigger, but it's simple. Because you see, number of headers value types are actually smaller. So here, this is IPv4, and here, this is IPv6. You see the source address and destination address same, but bigger space. Because it's 4 times bigger than the IPv4, like 128-bit. IPv4 is just 32-bit. So this is the source and destination address, but you see the gray color, they are same. Like here, there is a version field on the IPv6 side. That's also a version. Basically, it's 6, it's 4. Why you need version in the header? Because your router will see that and will understand, oh, this is an IPv6 packet, and this is an IPv4 packet. And then there are some type of service which is now called traffic class. So the green color, the functional is same. The name changed and position changed. So you see the type of service become traffic class, function same. It's to identify what type of service it is. If you want to do some quality of service, QoS. Time to leave, TTL. TTL is important in IP packet. So there is a lifetime of a packet. What is the lifetime of a IP packet? What is the lifetime? Or what is the TTL of a IP packet? What is the TTL? TTL is how long this packet will live in this world. Okay? If you do not have a lifetime in an IP packet, what will happen? if the packet does not find the destination, it's going to still roam around the internet cable in the media. It's going to occupy the bandwidth but cannot go to any places. But if you give a lifetime number, you are going to die if you don't reach the destination. That means it's not going to occupy forever the bandwidth of the internet, right? That is, you heard about internet loop? Loop means I'm sending, they're sending me back. I'm sending. If there is no lifetime, packet is going to roam around forever. And that way you can DDoS any network. It's a possibility. So the TTL, or time to live, is a lifetime of the packet. Every single time packet pass a layer 3 device or a router, it's gonna reduce one by one, and then next router another one, next router, and at some point it will become 0. Then if it does not find its destination by then, it's gonna be dropped by the router. So that's called TTL. In IPv6 it's called a hop limit. Same thing. How many hop it can pass? Tell me, how many hops? What is the maximum TTL? What is the default TTL of an IP packet? Okay, the TTL bit is 8 bit. So what is the maximum value? If there is 8 bit number, what is the maximum value? In binary, 8 bit number, what is the maximum value of number? If you put all the on bits, 8 1, how it becomes? 32. 24. Not randomly like that number. Not like that. Yes, that's the calculation, yes. I told you I have some gifts. So I have some so very interesting, but see, you're welcome. So I have really some very very interesting gifts. I'll have a quiz after. There will be a quiz. So that's interesting. The quiz prize. So I'm not going to distribute those now, but this is active. Like, don't fall asleep. These are for you. Do I have anything else? No, I have a screwdriver. I'll keep for later. So TTL is, so if you use a 8-bit number all or 1, that's the maximum. It's 255. So a packet starts its journey with the value of 255. That means it can pass 255 routers before the destination. Interesting, no destination in the world that is farther than 255 routers. There is no destination in the world. Internet is so connected, you will find the destination before you cross 255 number of routers. Okay. Protocol, it now became next header, and total length became payload length. Now the difference here, I'll briefly cover. There are some theory after that. I will skip those slides. I'm going to cover. There are some differences. As you can see, the header, there's some similarity. These are function is same, exactly same function, but name is different or position is different. For example, the protocol, it became the next header. The payload length is on the second row, the total length is on the first row. So the position different, but functionality same. There is a new field called flow level that was not in IPv4. It's unique to IPv6. This value is given flow to identify. So what is a flow? If your laptop is talking to Google in one session, that's one flow. If you create another session with Google, another tab and use google.com, that's a new flow. So there are 5 parameters that has to be same to define it as flow. That is your source IP, your destination IP, your source port, your destination port, and your protocol, whether it's TCP or UDP. So when we open a browser and browse google.com, your IP, Google server IP, your port, Google's port, and the protocol is same as long as in this web, as long as you are browsing that website. It's the same flow. But when you create a new tab and you start using google.com, that is a different flow because the port number is going to be changed from your side, and also Google will understand that this is a new flow. Otherwise, you search in one browser, the result will come to another browser. It doesn't happen, right? We can use in one browser, we can use multiple Google search engine, and if I search in one tab, it doesn't come to a different tab. It comes to that tab because it can identify the flow. So in IPv6, there is value that can uniquely identify one flow. There is no use. It is for the future. At some point we need to use it, we may use it. Anyway, this one is simpler. This one is a little bit complicated for the router to calculate because so many options mean the router need to be intelligent enough to calculate each and every field and understand. Now the problem becomes a little bit complicated because this header is 20 byte. This one is 40 byte. So the IPv6 is 2 times bigger than the IPv4. But IPv4 is not fixed header. IPv6 is a fixed header. So your router does not need specifically, because you can just say 40 byte for IPv6 is header, rest of the things are payload. But in IPv4, because it's a variable, you have to, if you want to do a variable logic, you have to do a different programming there, right? So this one, you see options, you can add multiple options. The padding, you can add multiple values there, so it becomes bigger. So that's not fixed. 20 byte is the standard, but then it can be bigger based on the value you are using. So when it becomes bigger, definitely it needs a special processing, and that means a processing delay. So the CPU, the processing unit of the computing device, router also got one, right? Router is a computer. So router needs a CPU. The CPU process this. Because this is the variable, the CPU needs a special processing there. So these are some of the things that has been improved in IPv6. And that's why some results of some tests shows that IPv6 is faster in many cases compared to IPv4. I already covered this part. Now let's go. So have you heard about the packet capturing? You can capture packet and analyze some security. Yes, sometimes the network admin needs to capture the packet. So if you capture the packet, what's inside the packet? And there are some tools. Have you heard about Wireshark? Wireshark. Wireshark, what is Wireshark? It's basically capture what? Human being. Shark. It's basically capture the packet from the wire. Means from the media. It collects the data and then it simulates the packet for you. So if we want to go here, let's say I click this one, and then if you click on that link, let me copy that, paste it. So Wireshark is an application on the computer, but the cloud is similar to Wireshark but on the web page. So we put an IPv4 packet and an IPv6 packet. So if you see, this is an IPv6 packet capture, and this is the layers. So this is an IPv6 packet, so you will see layer 3, right? So the first one is layer 1, the Ethernet layer 2, the IP is layer 3. So let's go. This is version. Remember their version? This is version. Let me bring the presentation. Okay. So you see first the version. You see the version is 6. Then the this is called traffic class. This is traffic class. Then flow level. This is the flow level. You can see. This is the payload length. This is the next header, hop limit, source address, destination address. As you can see like this. But if I open the IPv4 packet, and of course you can go and check this individually. This is ICMP packet, ICMP v6. So its payload is ICMP. So you see the ICMP information here. But if I want to check the IPv4 packet, let's copy this. And you have the slides, so no need to do that now. Let me just do this. A new browser, I'm just checking. And now you will see what is the difference. So this is the IPv4 packet. This is the IPv4 packet. And you can see the IPv4 header, the version is 4. And now look at the header. This is complicated, right? This one has more field, lot of information compared to the IPv6 header. Look, it's simple. So that's why the header processing is a little bit efficient in IPv6. So please spend some time when you are going back with the slides, with this packet capturing. Try to explore what are there, whether the fields are exactly same or we are learning here. There is an interesting part. You see next header. This one is a little bit different from IPv4. In IPv4, we have the options that can extend the header, so that's why it's not fixed. But in IPv6, it's fixed. But if I want to enhance the capability of the protocol in future, how can I do that? The header needs to be changed, but the header is fixed. How can I change it? That's why there is something called next header. That means if you need more information added to the header, you don't touch the main header. You put a value there and mention that this is not done. There is a next header that you need to count. But the main header not changed. It's the same. So that's why it's the next header. Like here, this is the IPv6 packet. The next header value means it's a TCP packet. If you say 6, it's a TCP in the upper layer. If it is 17, it's an UDP, right? And so here, the next header is 6. That means there is no next header immediately header, which is the TCP header. But if it is not 6 or 17, something else, that means it will not immediately start the layer, next layer or data. Instead, there will be more header information here. That means now header can be big. The main header is fixed. You can optionally add new header. That's why it's called next header. And this way you can actually add more functionality to the protocol without changing the protocol header itself. Keep the header like that, but add new functionality with the next header value. It's like a pointer that points to a new header, but don't change the header. Okay, now comes, so like I said, either 6 or 17. Until 6 or 17, everything will be counted as next header. So here is an example. Let's say I have a IPv6 header, I have the next header TCP, but I need to add more header to do some functionality. So I can do the extension here. Instead of directly from IPv6 header to TCP header, I can have now something added to this value. But now this is not part of the main header. This is part of the payload. I'm taking space from the payload, not extending my header. That is the big difference from IPv6, IPv4. So yeah, I can say my next header is hop by hop. The next header is destination option. Next header is routing header. So I'm like giving new functionality there, but my main header is same. Here, this is a chain of multiple next header. Because this is an, I'm just up to this point, I'm just saying that my main header is 40 byte. But as you can see, the next header value here, instead of 6 or 17, it's 0. Now my router will understand, okay, the header is not done yet. It would be done if there is a 6 or 17 there. Because it's not done, it's going to see what is 0 means. 0 means hop by hop. So this is the after the main header is done, there should be payload. But not payload, because router understood that more header is waiting, not. It's looking for two values, 6 or 17. 0 means not yet done. So it comes here, it finds it's a hop by hop header because 0 means hop by hop. And then this header has a next header of 43. It's not 6, not 17. That means header is not done yet. So 43 means routing. So that's a routing header. Routing header has a next header of 44. So 44 means fragment header. So this is the fragment header. Fragment header has a next value of 60. 60 means destination options. So this is the destination options header. It has a next header of 6. Now router understand, okay, that's done. So 6 means it's a TCP packet. So my header is all done in IP layer. Now I have to go layer 4. TCP is layer 4. So the next header starts. So without extending the main header, I'm taking it from the payload to increase my header values and give new functionality to the packet. Okay, that is the improvement. Anyway, there is a similar example in the CloudShark. You can see that fragment handling, like I said, path MTU discovery. Here's a visual diagram which covers the theory. Now take a look at this. I'm a host. My IPv6 address is this. This is the second host. I want to send some packet to this destination. Now this IPv6 packet, my IPv6 header and the payload or TCP segment, I want to send it, but my packet size, this packet size is bigger than my path MTU, my cable. My cable is connected here. This one is 500 byte, but my packet is more than that. Remember I told you that moment you have to fragment it. You have to make multiple. So what I should do, I should divide the packet. So I'm going to divide it into 3 packets because that means I need based on the maximum unit, maximum transmission unit. So every single segment, I need a IPv6 header. When you segment your main packet, you have to level. If you send a package, if you want to send the package, you go to the courier service provider and they will say, we don't carry that big. You have to use our 3 boxes. So they gave you 3 boxes. Do you put source and destination in one box or every single box needs to be labeled with this? You have to have those labeled in every box because box is going to go there. So header has to be in every packet. Then you also have to have a fragment header. You did a fragmentation. The side need to know which one is first, which one is second, which one is third. You need to have some label. That's called fragment. So this is the need for an additional header. You see why I need more header? Because I want to add some more functionality. On the other side, somebody needs to understand that the first packet is this one, second packet is this one, third packet is this one. So this, and then the next is the payload. The payload comes from this side, okay? Now it goes to the other side like this. And can you see the TCP header is not here? Because that was the payload. Don't need to repeat that. On the other side, when they get the whole information, they will remove these two. So these 3 packets come this side. When host 2 receive these 3 packets, it will remove the first and second header, first and second header, first and second header. Eventually the TCP header and the other things will become one big packet like this, right? It was originally the same packet. That's why I don't need the TCP header 3 times. I need the IP header 3 times because single packet will go there individually. How do you find out max transmission unit of the path? Like I said, in IPv4, you don't know about the whole path MTU, but in IPv6 you can do that. So here is an example. My laptop is connected here, and this is an Ethernet cable, and I it's a 1500 byte of MTU. But here, this network admin, for their own reason, for some VPN config or for MPLS config or whatever reason, they reduce the MTU to 1300. Right? Now in IPv4, you start 1500, it comes here, and then from there it cannot go. So what it will do, it will break it into 2, and first send one, the second send the second one, then this router has to adjust, means it's a reassemble them, right? But here in IPv6, it first try 1500. So first packet goes out, its MTU is 1500. Why? Because it can only know its own interface. The 1500 packet comes here. You can see that the packet size, this is a fragment header for IPv6 because it has other packets, but at the moment the 1500 packet bytes and with additional header of 10 bytes, it's going out. Router 1 receives it. Router 1 checks the best path. The best path is towards router 2, and this link is 1500. So it doesn't need to do anything because it's 1500 and the packet is also 1500, is going out. Router 2 receives it, but the destination is towards router 3, but it's not 1500, it's 1300. So what it's gonna do? It is going to drop the packet. Because in IPv6, the fragmentation in the middle will not work. The hop by hop fragmentation is by default disabled. So it will drop the packet, it will send an ICMP reply to the source saying that, hey, you send me 1500, but I cannot process it because towards the destination there is a block. You need to send me maximum 1300, then only I can pass, otherwise I cannot do that. Okay, so this information comes back to host 1. The packet size too big. This message will come. And that is an ICMP v6 packet, remember. The reply comes as an ICMP v6 packet. And once this comes here, the host packet size, and now it does a recalculation and fragment it with 1300. So now 1300, the packet size is now 1300. It will cross router 1, it will cross router 2, it will cross router 3 and router 4. This way the whole path is identified and the optimum and maximum MTU is as 1300. That means nobody in the middle needs to do anything else. The path MTU is discovered by this. Now you can say, like, if I'm sending a packet, suddenly the admin, but my session is still going on. It can happen, right? Some network admin will change the network config anytime. But I don't know, my session is going on with 1500, what will happen? The moment it identified, it will send me the packet too big and I have to retransmit again, right? So this way, it's not a problem. And ICMP is very lightweight. So even if you get this problem, it's not going to take like 1 second. It's going to be very fast because ICMP is very fast. So this was a very quick, and the next presentation, before going to the next presentation, we'll do a lab. Are you okay with the presentation? Any question? I know a lot of question is coming in your mind with IPv6. But yeah, in general, if you have any question about what we covered, let me check the Menti page as well. If you have a question, if you want to ask it now, you can do it. But let me also check the Menti. Oh, there is no question. Okay, so we'll do a quick lab setup, okay, for you. Let me just set the lab very quickly, and then I'll give you access. How many people we are here? If we want to give routers to everybody, let me see, 3, 6, 9, 12, 15, 18, 19. Are you gonna practice as well? 3 of you. You. Okay, so 22. Yeah. First, I will just look at the numbers, then I'll create the lab like that. So 22, 28, 30, 33, 6. I need to run 14 into 3, 42. But we have about 46, 7. Okay, let's okay, I'll run the lab, and then we'll get about 42. Let's see. Very quickly, I'm gonna run 2 labs and see. So if two of you want one router, that's okay. That's possible. I mean, I mean, you two, it is configured. So anybody wants like a group? Two of you wants one router? You two, okay. I can give as many because these are virtual routers. So we have more than 60. We have about 56 routers. Yeah, and if somebody missed bring the laptop, you can group together with another person. Okay. So they are gonna do one router together. Else here it's a Cisco router to configure. It's a Cisco router. So I'll start assigning the routers. Are you okay? Individually, right? So router 1, so we'll have 3 to 4 infrastructure. 7, 8, 9. Nobody here? Should I assign or not? Again, okay. Okay, no problem. No problem. I'm gonna assign, and then who is gonna configure for her? You will configure. So what was your router number? I forgot. So that will happen. Like I will forget. You have to remember. 9. So you are 8. 9, 10. 10. So you now have to remember 2. 8, 10. 11. 9, 10, 11, 12, 13, 14. That's done. Now if I say you 15, actually you were router 1 for the second group. But I'll go 15 because I have to finish until the second group. So, okay? 15 means 1. 16 means 2. And you will see when I show you in the screen, you will understand that 15 means 1. I'll tell you why. So 15, 16, 17, 18, 19, 20, 21. You are 22, 23, 24. Okay, 24. 24. Now, let me see. I think some of them can come this side. No need. So 25, right? 24. 4. 24, you need to sometimes talk to 7, 8. You have to end up and come here to talk. That's what I'm saying. If some of you can decide, I have to finish 28. I can assign you here, but the problem is then tomorrow when you are working as a group, is working to them. Why it's not working? You have to troubleshoot. Then they have to that side, they have to one side. It's going to be difficult. So how about you? 4 of you, 4 come this side. Try 4 of you come this side. Yeah, I got 4. Thank you so much. Thanks. I'm sorry that locate you. Yeah, you have to come. Yes. So, yes, sit here. Yeah, you can take any seat. I mean, anywhere is fine. Anywhere is fine. Yes, that seat is all fine. Yeah. Yes. So, 24, 25, 26, 27, 28. Please remember your numbers. Okay? 28 done. Now I'll assign from this and let's see how we go. We go 1, 2, but this is like third group. You are the third group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anybody here? 11, 12, 13. You are together, right? 13. Done? 13, 14, 15, 16, 17, 18, 19, together 19, 19, 19, and then, okay, great, no problem, 19. So remember, from 15, so I went all the way to 20, but from 15 it's actually R1, R2, R3 again for a different group. But for the time being, remember R15, R16 like that, okay? Don't miss your numbers. Remember. Let's go to our event page and open the basic configuration lab. Okay. So this is the 14 router group. Okay. The idea, I'll explain the lab a little bit because tomorrow this idea needs to be done, needs to be working. So see, there is the 14 routers and R1, R2, R3. You are in gray color and AS10 or system number 10. That means you are one company. You have 3 routers in one group. So when you have to work together, you need to sometimes help each other. Okay, in one group. R4, 5, 6, 7. 4 of you a different company. Your AS number is 20. Okay, so 8, 9, 10, another different company, and 11, 12, 13, 14, you are a different company. Now 15, you are one. 16, 17, 18, 19, 20, and things like that. So when I show you the example config, R15, you will follow R1's config. Even though your router number is 15, but please follow R1's config. Similarly, you remember if your router number is 27, remember that you are R13. Okay, this way. I mean, try to remember. If still you are confused, let me know, okay? And if you even make mistakes, it's okay because it's a lab environment. If you make mistakes, I can do a back-end fixing. And real life as well, we break internet, right? Sometimes or most of the time. Yeah. And when the customer, we say, we don't know. It's your probably restart your computer. Okay. So yeah, we'll make mistakes, that's fine. Now you have to go to a jump host. So what is a jump host? Before accessing the device, you have to use a safe server. That's a jump host. So we are in this room. We are here in this ANC building, and the lab is running. So from this building, we'll go to a server, SSH, to the server. And then the lab is running in this area. Your routers are here. You will SSH from this, you will actually get connection to. So everybody will go to a server. This group, you will go to a different server. This group, you will go to a different server. There are 2 servers. your IP is 202, and you have to write it down or save it in your computer, because tomorrow, day after tomorrow, every time you are doing the same. So 202.1.97.43, and your IP side, everybody here, 202.125.9 50. Okay. Now, who have done SSH before? Can you raise hands? Who used SSH before to log into a router from your computer? Raise your hand. SSH to a computer. From your laptop, you SSH to your router or server. Did you do that before? Who? Can I raise your hand? Oh.
Our
Yes.
let me
Okay.
niya husu kita experience no agora dang iti serviço ne iha iti niya service fating ita usa ona SSH accesso ba iti niya equipment siri ready. Por exemplo, imi balo karik usa pati puti. Oh okay. They have.
Anybody using MacBook here? MacBook? Linux, like Ubuntu? No, everybody Windows? So do you have a Linux? Linux, who is my friend? Linux. Yes. You need to get, you should get a gift. Next. You don't need to install anything. You use your terminal, and I already know because you are an advanced user. Yeah. You use Linux as well? Or should have said that before. All the Linux users. Okay. Users who doesn't have a SSH client, something like the PuTTY. I mean, you need an application to log into that server. Do you have PuTTY, everybody? Yes. Now, I know that not everybody has it. So we have to, who doesn't have? So you have to go to a website and download the open source software. It's an open source software. Okay? Let's go to, if you Google, download, click download, and then when you come to this one, just download this 64-bit 86 middle, somewhere in the middle, party.exe. Download this one, party middle, and see that one, party.exe. Go a little, yeah, scroll down, more. Done? You done? Yeah, almost. Okay. Okay. Yeah. Oh, very slow. The other way, which is not good, but if anybody can give the software down and the USB, not safe. But if you are confident that it's safe, please help them. Yeah, that's. Yeah. Can you help them, please? Yes, let's help each other quickly to download and install that, because it's needed. If you have a USB, we can also, yeah, it's getting downloaded, because everybody downloading now, the bandwidth is occupied. Give a moment. If you already have, no need to download again, because it's putting pressure on the bandwidth. Okay. Okay. Now, while it's getting downloaded and you are installing, let me give you the instructions. Okay. So you will use the SSH. This side you are use that IP, and in your part you can save it. You don't need to write or memorize because you can save the session. Okay, write down this IP. Now, username will be APNIC. Password is training. So, SSH to the node, use the username APNIC, use the password training and to access that and see if you can access the server, the jump host. Okay, it's 202.125.97 and then 43. Username is APNIC, password is training. Port is 22, port is SSH. And this side you are going to use 202.125.97.50. Yes, the username is APNIC, password is training. Now, logging as APNIC. Not small. Yeah, try again.
Kolega sira nebe maka familiar ono ho acesso ho si
When you sorry.
Sorry.
You don't need any.
How about the TLnog?
SSH, right? SSH space APNIC at the rate 202.125. This is the IP of the server. 125.9.97 7.50. Save it. Save. Password will not be typed. It's hidden. It's hidden. You will not see. Just type. That's the beauty of Mac. Now you are here. Now which router you are? I'm 3. R3.
Oh, 17.
I'm 17. Yes, so type 17. Okay, so when you SSH to the terminal, you get a menu and you have your router number there. Select that number. So if you are router 5, press and then enter. If you are router 15, press 15 and type 15 and then enter. If you are already on somebody else's router, then exit out of that router. You are 14. Over there it should be 14. Incorrect password. APNIC. Oh, you have a space. Sorry, what did I do? This is not Mac, right? This one? This one? Right? You saved it, right? Okay. Yeah, APNIC. Enter. Yes, now it will work. There is no space. Previously there was a space. That's why it's not working. Yeah, do you need any help? Username, password training. All is small, okay? Yeah, training, yes. Training. Over there, over there. You go. Yes. Select your router number there. 16, just 16 and enter. Yes. Yes, enter. Yes. Now, once you are in the press enter couple of times. So you get the prompt. Once you are in the router, you see some logs, press enter couple of times. Yeah, username APNIC, password training. Maybe you can help each other. Just in case if your colleagues need some help. You done? You are router 12? Good, good. Yes, you are right. Everybody? Good? Downloading. Oh no, connection is not yet. Oh. Well, is it from the beginning or just started now? Just now. Oh. Okay, if you see it's not working, if possible, it's still not getting connected, inactive. Restart.
Now,
Okay, so I believe all of you got it. Okay, let me press it. TRAINING. Access denied. 202.125.19 AP 43 APNIC. SSH. Same problem? Okay, let me. You also having the, oh, your internet is problem. Okay. One and then enter. Yes. Okay. Oh, somebody is in your group. Who is in your group? Okay. Yeah, I think somebody. Okay. But this is weird. It's a group number. What was your group? Group one, and what is your router number? 6.
Ani meeting sayang. Oi main agak seru dan orang apa dan. Oi perum satu habis habis tu ni. Ah. Bagus ya. Head SSR.
So some. So okay, I think everybody got their router access. We may need to go for a break, but let's configure our basic part. I'll explain, and then we go for a break, and then when you come back, you configure it. Okay? But because before the configuration, I have to explain what you are gonna do today. So listen to that, and then finally we have only one person left, right? Your laptop is still having some issue, right? It's about connectivity. Oh, the connection is not working. One last try. Can you restart your computer? Just. Oh, you did restart already. The Wi-Fi setup, I'm probably having some issue. How about this one? Connect. Hold on. TLnog 1. And okay, let me come back again after talking. So even started, it didn't work, right? Something wrong with the Wi-Fi network here since the morning. Yeah, not yeah that one. Okay, connected. Now can you try? You are 25, right? Yes, enter. Yes, enter a couple of times. Yes, this is 25. Okay. Because of the so yeah, they got connected. Can you also restart the computer one more time? Oh, hold on. No internet. No, not this one. Actually, the lab, the room's Wi-Fi is this one. Actually, I'll ask the key. See if can we restart one more time? And once you restart, then I'll come, okay? Yeah, so before going to the break, let me explain the lab. Okay, so you already got this. This is not needed. We have the selection from the menu. You selected the router and you logged in. I did the backend connectivity to go through number 2. Number 3 is where we start. So this is a Cisco router. That means we need to know how the Cisco syntax, the commands are configured. So first thing is you see your router and then a greater than sign. That is initial access. It's called user execution mode. That's like it's like a general user. But if you want to configure to the privileged mode, that means you have to write enable, E-N-A-B-L-E. But in Cisco and in many other vendors, you don't need to write the whole command. Sometimes the unique characters and then tab auto completes the command. You write some command, let's say en and then tab, the tab keyboard, if you press, you see it will auto complete the enable part. So try to type en and then tab, press tab, en and then press tab, and then you see enable and then enter. Once you enter, you entered in the privileged mode, means you will see now hash. After your router name, you will see hash. So once you do that, then we will try configuring something. I have your host name, router name configured. So you don't figuring something. Okay? So go to this point, but don't use this command because it's already given. That's why you see your router's name. Okay? Number 4, start this configuration. We are turning off the domain lookup. In Cisco, if you mistype a command, it's try to resolve the name with IP address automatically. It thinks it's a name. So we have to do a DNS query. We have to stop it because otherwise your router is going to take some. No IP lookup. Try to do this command after config terminal here. After config terminal, don't use this command, use this command. And when there is a big part here, no IP domain, you just write do and then tab. You see it will auto-complete, okay? Yeah, try to configure. Everybody configure this. No IP domain and then enter. Okay? Point. Configure terminal. You just type T and then hit. Once this command is done, F4 is done, we'll for break and we'll to do the rest of the work, okay? If you have everything done. Let's save our configuration, okay? So we have to save it with the command write. Right, it is at the bottom of this page, but because we didn't finish the rest of the configuration, let's do a quick write. How do you quick write? You do do. That's why I'm using do. I'm saying do that, something like this. Yeah. You are in the config. So did you do the no IP domain lookup? No need hostname. Just do no, because hostname is already I configured. Now no IP domain lookup. Do you have the PDF? This line. No IP domain lookup. No, yes, no space IP space domain in tab. Use the tab. Press the tab. Yes. No IP domain hyphen. Yeah, press the tab now. Oh, why it's not working? No IP domain. No IP. No need. Look. Why? Yeah. Sorry. Yeah. Enter, and then do write. Minutes. Or later? Sorry. New announcement. Follow the next step, number 5. Line console 0. That means we are configuring for none. Then again configure line VTY 0 space 4. The VTY is for remote log, telnet or SSH kind of thing. In Cisco, you have you can actually type a name and then hit enter. It basically do a telnet fault. Don't want that, and that's why we will say no, you don't need to do that. That's why we disabled it. We will do manual config like SSH because by mistake if I type something and hit enter, it's gonna try to resolution. Disable it. Okay. Now, who could finish step 5? Step 5 done. If you are finished, you colleagues beside you, if they need any 5, the transport preferred none comments. Yes. Confirm. Yeah. Enter. Oh, it's inactive. I think it's gonna come. Yeah, it's for the internet, I believe. Panic and go to the config mode and go and open the PDF for step 5. If you finish step, whoever finished, go ahead for 6. It's a similar command. Will disable route. The no command means that means we are disabling. This is by default on. We'll disable it. Done. Step 6. So remember, if you can finish and your colleague or your neighbor beside you needs, please try to help each other. Yep, done? Yeah, good job. Yes. Yep. Line console 0. Yes. Then transport. TR. Yes. Yeah. Use. And then tab. Another Wi-Fi. Okay. Yeah. Okay. Who couldn't connect? I think he couldn't connect. Now you are okay? You connected? Okay, if you finish first day usually like this. First day everybody needs to be common understand, used to common understand. It's okay. The other thing is what you can do once they fix it, you can copy the command in the notepad. When you have the connection, you just copy it directly, no need to type again. Okay, so down from in the PDF, copy the commands and put it here, so you can do it faster when you get the access. Let me see if the coffee is ready. Yes, I think it's ready. So, Jemris. Okay, so if you have done these steps and saved it, you can go ahead for the break. Tea or coffee break. Come back at 5 past 4. 20 minutes break. Yeah. Yeah. Tab. Just type the whole command. You don't need to exit. If you want tab to work, you have to be in the right directory. Remember, it's looking for the command in this directory, but there is no such command. But if you type and hit enter, it will take you to the right one. If you want the autocomplete feature, you have to be exactly the same location. Console. So when you are in this router, you want to log into another, you can just enter. SSH, no need to say telnet, anything. Just use the IP. This is automatically going to use telnet to log into that device. And if you type a name, yeah, because if somebody can get router, can try to do, and hackers and attackers do. I don't need to SH and then I use the command already, right? But not now, not in modern device. Let's say there's a host name. Hit enter. It's feature is not previously when internet was saying internet was good. Then this feature was helpful because I don't need to type many things. It's easy. Just now name enter is going to do it. That time internet was safe. But now in this world internet is not safe anymore. So I
Kira coffee break radio na. Semak hotona bele ba.
yeah, come back
Coffee break
at
live.
5 past 4. Because we need to go back quickly to home, right? So yeah.
Fila tu kuira.
Okay, take a break. I hope you got your. Yeah, yeah, no worries.